Well, I did now. I'm certainly hope so. Yeah. I certainly hope that you guys remember the first piece, the first 20 minutes that we've been talking. Um, I'll go over that just quickly. Uh, Functionality, guys. Functionality is refers to the behavior of an application, the behavior of a software, the behavior of us human, the behavior of a toy. Okay. So when we're talking about functional testing, we're talking about how we can test what the specifications of that function is. Okay, specifications of the function. Once again, looking at Timmy raising his arms. Okay, so I will have to test if he raises his arms properly up, if they go down again, and if it goes down, does the second arm goes up, right? Because it's a pattern, right? One goes up, one goes down. Does the head actually move also when it does? So there's a lot of things there. That there's a lot of functions that Timmy has that we will have to go through, that we will have to test. And there are certain types of testings that we have to use in order to test that functionality, right? So, but we're gonna go on a quick overview of what those may be. Um, so when it comes to functional testing, um, and we want to do behavior, the main types of testing that you're gonna find yourselves performing, or at least seeing in an application, it's gonna be anything from smoke testing, sanity testing, regression testing, okay, user acceptance testing. And so these are a lot of terms that you haven't heard before. And again, we're going to go over them um, at a later time in more detail. But to quickly go on an overview of it, um, smoke testing, this is a type of testing that is performed before the actual system testing. Okay. Um, and I mentioned what system testing was on the last class, if you guys remember. So, but the main function of a smoke test, okay, and let me just say, a smoke test is really a term that really it means that there is a bed or a suite of tests, okay, test cases that really just glosses over the critical functionalities, okay, of the application to make sure that it is working fine in order to carry on any further testing. So this is, for example, if you happen to be in a team and you hear the word smoke test, you say, hey, or you're in an interview and you hear like, hey, so how big is your smoke bed? Your smoke bed shouldn't be, it doesn't, it's not that it shouldn't be, it could be, but it shouldn't be more than 20 test cases, really. Maybe 25 cases. It shouldn't be larger than that, really, because um, you're only having the main test cases that will test the critical functionality of that application to make sure that it is working. That for example, like if you get a deployment into a different environment, and we're going to go over those terms later, um, we're going to do smoke test. So that means that we're going to run the smoke test to make sure that the critical functionalities of the application are intact after the new deployment. So what the new deployment means is that we're getting new code. So the developers worked on something, and that was done in we're gonna call developer environment, but that code is now being deployed. So deploy sending is being sent to the QA environment. In the QA environment is where you guys test. So when that gets sent over to the QA environment, um, we want to make sure that it didn't break anything that was already existing in the QA environment. So what do? We run a smoke test. Okay. And so this is how we make sure that we're not going that we're not that the application is not broken, that none of the new code introduced is affecting the current functionality of the application, as we wouldn't want that. Okay, I also mentioned integration testing during the last class. And so integration testing, this is really performed when two or more functions or components of the software are being integrated in to form the system. So going back to system is a end-to-end process, right? To make sure that the full system itself works. Now, integration testing, uh, um, expecting that this is two or more functionalities being introduced. Now, these functionalities can be introduced in the beginning of the system test, or in the middle, or at the end of the system test. Nobody knows, who cares? So it's all about the requirements, right? So this is really what integration testing means: to test any integrated piece of code, of work, or functionality into the system or into the application. Regression testing, this is mostly carried out by the systems team. Um, but regression testing, really just like smoke test, is a suite, is a bed of test cases. But this is a lot larger than the smoke test. The regression test bed, in fact, can be as large as 2,000, 3,000 test cases, right? For a large application that just continues to be updated and continue with continuous maintenance. And this is, this is for a really large application we're talking about here. And so running 3,000 test cases requires a lot of tools, requires a lot of DevOps, right? Um, so we're gonna go about some of that. We're gonna go over some of the stuff later as well. Um, but regression testing is really important because excuse me about that. Unlike the smoke test, unlike the smoke test, um, all this say 3,000 test cases, um, we run it to verify whether there is whether there is an issue in all of the existing functionalities of the application. Okay, so like not only just the critical pieces of it, whether like the page loads, um, login is working. No, it also goes into the login. It goes into the clicking on this page and this page and this page and this page and filling out all of the information, all of this stuff, right? So it goes into more details, all right, all of these test cases. And so a lot of the times it's also run after every build, again, going back to the deployment, as I mentioned before. Once you get a deployment, the right way to do this is that once you do a deployment, right, now you run the regression bed to make sure that nothing is broken, or if you had a bug fix, right, a defect fix, you also want to run the regression to make sure that um, any code that was introduced, because bug fixes that touches the code also required deployment. So you run the regression to make sure, once again, that nothing is broken and that the new code is not affecting the application in a negative way. Lastly, you have UAT, user accepted testing. And this is, again, more, as I mentioned in the last class, this is more for the business folks. So the business folks or business testers, um, these are the guys that really handle that piece because they work with the application. They in a sense could be the end users. Okay, so they really know the application from a business perspective. Um, and so their test cases may be a little different than the QA tester. Now you may, if you're in a Scrum team, you may or you may not have a UA tester, a UAT tester. Um, but regardless of whether that is the case or not, um, during a release process, the UAT tester, the business tester, does take care of the UAT business there. So, which normally happens in a different environment, in a higher environment. So I say higher environment because, let's put it this way: developer environment sits right here, QA environment sits right here, then there is UAT environment, which is right here, and then there is production. Okay, so production is the last phase. Production, once it's in production, that means it's live. So it's always in that format. First is in dev, then in QA, then in UAT, and then in production. Okay, unless we're doing blue green, but blue green is a lot of advanced stuff, which I'm not going to go over today. But blue green in essence is like just really having the ability to have all the environments uh, all synced up and being able to just switch off from, okay, UAT, switch it off, go green, it's in production. Okay, so but that involves a lot of more advanced discussion and DevOps talks, but we're not going to go there yet for now. Okay, so do you guys have any questions about functional testing, or the types of testing that exist in the functional phase? Okay, good. Now, non-functional. I'm gonna go over this quickly, but non-functional testing really touches on the performance. When I was doing this earlier, somebody mentioned flexibility of the shoulder, right? This is the type of non-functional testing, because what it's doing is gauging the performance of the shoulder instead, not the behavior. So when you're talking about flexibility, when you're talking about amount, when you're talking about, content, this is a type of non-functional testing, which mostly relates to performance testing. So in essence, what it does is that it checks really the quality of the software to be tested, in the sense of time, accuracy, stability, okay, correctness, durability. Okay, so this is what non-functional means, and this is what non-functional leads to. There's a bunch of tools to do this kind of test, which we'll go over again later. There's a lot of stuff we're going to go over later, guys. So be ready. This is just the beginning. You have no idea what's in store for you. So this is something that you cannot do manually. This is something that you require a tool to do. And mostly this is going to be performed by the software engineer, by a QA engineer, not a manual tester. So if your role turns out to be manual testing, that's not really something you're going to worry about much for, but it is good to know regardless. Or if you go into the automation field, then it's also good to know. That doesn't mean that that's what you're going to be doing, but some places do include that in the requirement. But more often than not, there is a separate team that deals with the performance issues, with the performance testing. And even if you run the test, really that the rest of that just goes into a separate team for troubleshooting and whatnot. And so what types of testing are we talking about here? So when it comes to performance testing, we're talking about load testing. So load testing really talks about handling the workload on an application. Okay, so by handling the workload, it could be response time in a real environment. So what it will be like, its ability to function with a heavy load, for example. So a heavy load, say in a case of going into into Zoom actually. So going into Zoom, like this guy's probably did a bunch of performance tests and continue to do on Zoom because they want to test how well the application would run with 1,000 users in a meeting. Would it cause any problems, right? So that kind of stuff. That doesn't seem exactly as realistic as I hope. Then there is stress testing. So in stress testing, the application, so this puts the application in a state of extra workload. So to see how efficiently it'll run and whether it is able to handle the stress of the requirements. So for example, so going back to Zoom, so you have all right, let's put two scales, right? Or let's put just a walking plank. This walking plank, um, we're building it for its stability and durability. So in this plank, we're putting two people, right? And now we're testing if the plank can hold two people. That's the baseline. So now we want to test it on we want to do a load test. So now we're going to increase the baseline to 5 people. So now we got 5 people, and now we're seeing how the plank is working. The plank is working, it's stable, but then we got a peak, like we got a rush hour. So now we want to test the rush hour, and then 10 people get on the plank. So this is putting the stress on the plank. Okay, so we want to see how the plank is going to react, its stability under that stress. Okay, so it's that similarity there. So there's also volume testing. Volume testing is it's mainly like, not like, let's give you the right context. It's its ability to handle data. Okay. So in a real-time environment, we want to see the correctness, the reliability under any extreme conditions, adverse conditions. Okay, so this is where volume testing leads. And again, we're going to go over all of these testing types in more detail, one by one, what they mean and what they do to be exact. Sorry. All right, just send it to Shanto. Taslima. Yeah, thanks. All right, so then we have endurance testing. Endurance, what we're doing is, what we're looking for is really the consistency of the application, right? So on repeated usage, that plank that we were testing, that we were stress testing, we want to see its endurance. So now we want to check its stability in under constant use. So every day we're using it. So for about 10 days, we want to see what it looks like after 10 days. Is it still working as expected, right? So there's that. There's more to it. There's usability testing, there's security testing. So there's a lot of stuff to look into for non-functional testing. But again, something that we're going to be seeing in a different class when we go into each type of testing in detail. But again, to recap, functional testing, what is it looking at? It says what the product does, okay? What the product does is behavior, the operations and actions of the application. For non-functional testing, what it does is that it checks the flexibility, it checks the consistency of the application. The functional testing is mostly done under is done basically on the business requirements. Whereas non-functional testing, this is more performed based on the customer expectation, um, and the performance requirements. So this is not so much as business requirement, but you know, expectation and the specifications. Um, Functional testing, it tests really whether the application or behavior has the right result. So you know, whether it works as expected. Uh, Whereas the non-functional really just checks response time, the speed, um, under those specifications, you know, stability. All right, so I'm hoping that you guys are gaining the basic understanding of both functional and non-functional testing. Um, we're exploring some of that. We're exploring some of the different kinds of testing that exist, um, but we haven't really explored the types of testing in detail. So this is really just high level. Um, and so this is really just to get your feet wet, to test the waters. Okay. Um, but it is good to know what functional and non-functional testing is. Once again, this is something that goes hand in hand with your understanding of software development life cycle. So I'm hoping that this is going to be insightful for you. Now we're gonna get to the meat and greet of things. Now this is where you guys come in. This is the real deal. This is as real as it gets. Wow, I feel like I'm scaring you guys. Okay. So STLC, what is STLC?
Software testing lifecycle.
That's right. The title is right there.
See that, I can see that.
That's correct. So software testing life cycle. Now this uh, is a big part. In fact, it is why we're here. Um, Software testing life cycle, guys, and as the title explains, is a software. Is that explains, but as the title implies, it's really the phase in which you, I, the tester, comes in. This is where you begin going over your requirements. This is where you come in and you start going over the design. This is where you come in and you start going over everything, your test planning, your test execution, and whatnot. Like this is where everything you do happens. And this is also, again, integrated into the SDLC format. Um, and so I'm going to show you really just a quick clip of, not clip, but a quick overview of what it will look like, what it looks like with a linear, on a linear format. But the SDLC has a set of steps, just the same way that the SDLC does. Okay. And so we actually already answered both of those points. Good job, me. So again, what is SDLC? Is really the sequence of a specific actions that we perform to begin testing the application, or to begin the process of testing, to ensure that the software objectives, that the software functionality, that the software requirements are met. Okay. Um, it includes different forms of testing, and really what it makes sure, what ensures, the way that ensures it does is by checking the verification and validation of the testing. We're going to go over what is verified versus validation. So that's also an interview question that happens sometimes. Um, and now I just want to make sure now that um, I mentioned this just a moment ago, but this goes hand in hand with SDLC. So I want to make sure that you guys understand that this is not a separate process. It may seem like a separate process because it has its own phases. It has its own title, but it is within the software development life cycle. So it really goes just hand in hand with it. Okay. Um, it's just that instead of everybody now in the team, this is really the tester really going through a series of steps. Um, okay. And so these steps, once again, or I'm going to say them now, um, they are very similar to the software development lifecycle. And the way they are similar is that they also have a requirement analysis. They also have a planning phase. They have a design phase. They have a development phase. They have the testing phase, and then sort of a deployment phase. Okay. And we're going to go over each of those um, individually because they do differ from your typical software development lifecycle titles as well. So again, what do we use it for? Again, we use it for to test. We use it for to test the functionality, the validation of the application. You know, we're measuring the behavior that we're supposed to know. Okay. Um, and it contains various stages. Again, as I was mentioning, and such as planning. Um, it goes into implementation. It goes into controlling. Okay, let's not use those words. I don't want to confuse you. It goes through the series of phases, the same similar phases as SDLC. And I keep repeating this because it's important. You're gonna need to know it. It goes through these phases to be able to test the application. In a way, it is used for both functional and non-functional testing, not only functional testing. Because regardless, you have to really do the same thing. You still have for non-functional, you still have to develop cases. You have to go through a series of steps, which again are all part of the SDLC process. And so its role, as I mentioned earlier, the SDLC and even the SDLC, they're closely related. However, they do still feel like two separate entities, but they're closely related because they actually go hand in hand. And so we're going to go a little more into that. So you're still collecting the requirements. You're still creating a design, right? You're still analyzing those requirements. You're creating a plan, right? After that design, you're implementing that design. Then you're testing that design in the form of execution, right? So it looks like something like this if I were to put it into linear graphs, right? So if I want to put it into linear graphs, this is the SDLC right here, the straight line. And then this is the SDLC here on this curvy line here. But as you can see, it begins going on a wider range, but somehow I want to use my pointer. I like my laser pointer. Don't judge me. So it goes into that line here. We're looking at this straight line here, but then we see the gap here, how big it is. But then as we move closer and closer and closer to the test execution phase of the SDLC, we see that gap getting narrower and narrower, so closer and closer, right? And then it splits again. So looking at it in the requirement analysis, the planning and the engineering or design, we see that there's some sort of gap here. So like, what creates that gap? Okay, what makes the SDLC be so apart and yet follow the, not the same exact, but closely to the similar design of the SDLC? And so for that, we're going to go into the phases once again. Just like software development lifecycle, software testing lifecycle contains a series of phases, and those are requirement analysis, test planning, test case development, environment setup, test environment setup. We talked about environments earlier. So test environment setup, then we have test execution, and lastly we have the closure. So how they relate to each other, you're about to see. So the SDLC phases. What we have here is, what we're looking at here is a list of those phases that I just mentioned to you. And if you start really paying close attention to it, it looks very similar to what the SDLC looked like. Okay. So just now I showed you, or I reminded you, so to speak, the phases of the SDLC here process. But now I'm showing you a different set of faces here. But when you really take a close look at it, it looks the same or almost the same. The only difference, or the major difference, is here that each of these faces, at least most of them, have the word test embedded in them.
Can I say something?
You may.
So SDLC is like, it helps to develop the quality of a software, right?
SDLC?
Yeah, no, SDLC.
SDLC?
Yeah, whereas the SDLC, it helps to find the defects in the software.
Yes and no. Yes, because using SDLC helps us find the defects. No, because SDLC is not really the main focus of the quality. That will be, quote unquote, the SDLC. However, in Agile, the overall quality of the product is really everyone's responsibility. In other words, the entire process of SDLC and SDLC now. In waterfall, if we were talking waterfall, yes, your assumption would be correct, with the exception of the SDLC. Now, the SDLC will find the quality, defines the quality and the bug findings, okay, which in turn turns into what the quality should be, right? SDLC in waterfall is really just the process of building a software product with a set of steps. Okay, it is a process. It is a manifesto, so to speak, that guides us into how to build a software product. Okay, so once again, the way that guides us is by doing a requirement analysis, doing a requirement gathering and analysis, doing a design, where architecture comes into play. So, you know, between that gathering and design, how do we put all those things together, right? Because again, building a software involves a lot of different things. It involves setting up environments. It involves setting up databases. It involves setting up, APIs, for example, right? So it involves a lot of things. So how do we put all of these things together? If it requires, if it's linked to the data warehouse, right? So now we need a data warehouse team, right? And the data warehouse also has its own flow. So this is where design comes into play, okay? In the SDLC process, we don't have that in SDLC. SDLC is a little more straightforward. What was that? In SDLC, it's a little more straightforward, right? And I forgot to disconnect my phone from the, all right, so let me just disconnect the phone from my Bluetooth because it's connected to my computer. Shame on me, I will give you guys that. Okay, back to business. Did you guys hear all of that? Hello, can you guys hear me?
No.
Yeah.
Yes.
Yes.
Okay, don't leave me hanging here. I'm thinking that I'm talking to myself. Okay, so, which is okay, so long as I don't respond myself, because then that means I'm crazy. So now going back, come on, guys, you guys can get a joke. Jesus. You guys are scaring me here. Okay, fine. No more jokes for you guys. It's a serious group. So requirement analysis, test planning, test case development, test environment, test execution. Okay, this is all the stuff that we're seeing here. And test cycle closure. These are the phases of the software testing lifecycle. Now this graph right here, it actually gives us a little more, a better visual into how it all comes together, into how it all works. So you're gonna see a couple of more steps here, but then again, remember that analysis and requirement gathering goes hand in hand with each other. There is, however, a different thing here that we're gonna go over in a moment. And so requirement capture and analysis, right? Saying that it goes hand in hand together. Say this is a 1 step to 1.5 step right here. Jumping into the test planning and scenario design, okay? Because now that we had the requirement, right? Back at the requirement gathering from the SDLC process, we got the analysis. Now we also have that information, okay? So now that we have that information, we start preparing a test planning. We start going through a test plan and scenario design, right? This is high level. This is all high level. So this is where we start figuring out what kind of tests we're going to do, what we're going to be testing, the functionality. Does it require non-functional testing, right? We're going to go over all the functional aspects and the specifications of it and start creating a high level test plan and scenarios design. Right. So once we have this, and now we go through the process of all the agile ceremonies, right? Of sprint planning, sprint grooming, right? All of this stuff. So now we start going into the test case development phase, right? In agile, this is all happening in a single sprint because you have the user stories. So now that you have the user stories, that's a requirement capture, right? An analysis. Now you do an analysis of it. So that's all in the user story. That's your first step. The first step. Now that you have that in Agile, now you go into the test planning phase. So now this is no longer more high level. This is now, the specifications. You can come up with questions. And so you design your test cases or your test plan based on what those requirements are. And again, remember, it goes in Agile, we break it down to a granular level. So it really shouldn't be a lot. It's not that crazy. If you have to write a lot of test cases, then it needs to be broken down. But you know, communication with the team. So moving on, now that you have that test planning, now that you have the scenario design, now you're going to the test case development. So based on this requirement, based on your design, now you're saying, okay, I got this. So now I have to move into my development. So you start writing your test cases, you start writing, um, you start inputting all your test cases and whatnot. And so with this done, what happens is that you now move into the execution part. Execution is very important because in the execution, as you see here, it's where you'll find defects, if any. And let's be honest, if you don't find defects, then maybe you're not doing the right level of testing. So this is something that should help you in the future. A tester is not there to make sure that there are no defects. A tester is there to find the defects. Okay. So your job is to find them, not to make sure that there aren't any. That's a developer's job. Your job is to find those defects, because when you find those defects, that means that you're helping in the quality now. Okay. So very important. Mindset. And I said this before, mindset. Your mindset is to break the application. You want to figure out a way to break the application. So you design those test cases. You write those test cases with the intent of finding every little piece. Okay, the most critical parts. Okay, the every single piece of the behavior of the functionality. And if you do that, you'll find defects. And if you find defects, you're doing your job right. So test execution, you find a defect. If you find a defect, then it goes into its own life cycle. And we're going to go over that quickly before we go and class today. But defects or bugs have their own life cycle, which is called bug or defect life cycle. And so if that's the case, in your execution, you find a defect, then it's going to go into that life cycle. And this little section here has its own life cycle, which then expands. And so we're going to go over that in a moment once again. But say now, assuming that everything is correct, now that you don't find any more defects, and you run all of your test cases, and now you're moving to the next step, which is the test cycle closure. Now, test cycle closure is now where you just and your testing phase, and so you go over those results with your team, right? To make sure that that you really caught everything. And so your team is gonna say, okay, yeah, so you covered this, you covered that, you covered that. Okay, results positive, all pass, good. Then we're happy. We move on. We move on to the next story. We move on to the next iteration. And so that is those are the phases of software development lifecycle, software testing lifecycle. Excuse me, they sound the same. So now, what's our conclusion? So now that you know that SDLC and SDLC go hand in hand, but now you know what each of them are used for. If we had to look at the graph now, again, we have a clear vision of how they interact. So more than anything, we look at that curve that we saw earlier, and we see where it collides here in that test execution. So what this means is that you don't start your testing in the software development lifecycle. You don't start your testing at this phase. You start your testing at this phase right here. This is where your testing begins, in the very beginning. If you're starting your test here, then you're late. And so that is gonna, that at the same time is going to end up, if you find something, if you find a missed requirement, it's basically just like doing waterfall model again. it's gonna set your team back all the way over here again. So make sure in the future, say when you get yourselves a role, a job, that you are following this process. You start your testing in this phase right here. You don't start it at the test execution, because if you start it here, you're late. When you get the requirements, you do your requirements. When you're in the planning phase, you're also doing your test planning. This is all hand in hand. Okay. All right. Do you guys have any question about test, software testing lifecycle? No questions at all? All right, we're gonna do an interview at the end of this session, and we're gonna see who's on point. Did you guys hear that?
Yep.
Okay, you guys are badasses then if you, all right. Look at you guys go. You guys are gonna pass this test in a heartbeat. You know what? Who said yeah the first time?
That was me.
Sayed. Sayed.
Yeah.
All right, Sayed. All right, smart boy. Know it all. Let's talk for a little. So, based on what we discussed of software development lifecycle and software testing lifecycle, what is your takeaway from that?
They are both very similar, like you just stated in the conclusion, where you have your requirements, you have your planning, the design of it, and then, the test execution and all that. It's I do feel like it's very, very similar, almost to the fact it's like you're doing like nice Doritos. But yeah, so like it is very similar, and the concept is one and less the same. You're going through each phase like it's waterfall. Then you move on to the next and to the next, and then you test it, and then you go back if it doesn't work, and then so on, so on.
Okay. Okay. So, where does software development lifecycle and software testing lifecycle really converge?
After the test execution.
You fail.
You converge meaning like when they go apart or come together.
When they come together, when it's
Oh,
happening.
it gets narrower towards the test execution, and then it gets further off after that.
It gets narrower, but
It doesn't like pass through each other. It never touches.
no, it doesn't collide. It doesn't.
Yeah.
It doesn't.
They never touch.
They don't collide, but they converge. In other words, they still work together. This is just a closer convergence right here. But the convergence begins right here.
From two
I see what you're saying.
analysis. Yeah.
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 See, Sayed? All right, but that's very good. Yeah, so remember, it's not, again, if you think that testing begins at this stage, if you think that you begin your testing is the LC in the SCLC in this stage, you're running late, you're running behind your team, guys. It's important that you begin at the same time. Okay. Good explanation there, Sayed.
Thank you.
Okay. Now, as I mentioned before, bug defect life cycle. Yay, bugs. Who likes bugs?
Nobody, bro.
See, everybody's
way.
quiet here.
I do.
Okay, there you go. Thank you. I like bugs too. I like, when I was a kid,
Ladybugs?
like I used to play with bugs. I used to play with like nasicadas. I used to try to grab the
Probably put them under a magnifying glass and the sun pointing at them, huh?
Yeah, you know, ants
Oh
are
no,
bugs.
that's psychopathic. No.
Yeah, I mean, that kind of stuff is, let's not talk about that. But yeah, you know, we used to play with them. As you're a kid, they were fun, okay? Since you're become an
That's just
adult.
nerd 101.
Sure,
playing with
maybe not
bugs.
101. Sure, why not? Hey, you know. But okay, so what we're looking for, the bugs that we're looking for here now, they're not the same kind of bugs that we're thinking. Okay. These bugs, they are digital bugs. They exist in the matrix. Nobody here a Matrix fan?
I am a nerd. Come on.
Okay, thank God, somebody, just one. Wow. It's a lot of people here. You guys need to go watch the Matrix, all four of them now, not the trilogy. All right, so what is defect life cycle? So defect life cycle is essentially where we touch on back here. Okay, that's where it begins. So a defect, what is a defect? Let's see. What is a defect, Arifa?
Defect is when something's wrong with something.
Okay.
Are you asking me the definition that's in there? Like
No, you don't.
defect life cycle?
No, you don't have to give me the definition that is there. Just give me what you think is a defect.
Something, probably something broken.
Okay, something broken. What else?
Something and that is not as in the requirement. Just like a bug, probably.
Okay, well, yeah, so defect bug. Okay, let's see, Sultana. Can you tell me something else?
I think it's a problem or issues in the software, and because of that, software I think will not work properly.
Okay, but outside of software, you know, outside of the software now, Taslima, can you tell me what a defect means outside of software? Or bug? Yeah, well, not bug, because outside of software, a bug is a bug. But a defect, what does defect mean outside of software? Just a word, just one word. Taslima? Or Ali? No?
Imperfection, can we say that, or lack?
Imperfection? Okay, I mean, nothing really in reality is perfect.
Or
But we try to-
fault? We can say fault.
Faulty, okay, faulty. Go ahead.
Error or glitch, something happened in the software.
Okay, back to software, yes.
Problem. It's a problem in a functionality of the software or any kind of thing. It's a problem in a functionality as expected.
Okay, good. And Taslima, I couldn't hear you now. You can type it, you can type in the chat. It's fine too. So it shows that you're muted, so check your mic. You're muted on the mic. Maybe you have a double mute. Now you should be able to talk. Oh, no, I still can't hear you. Sorry. Okay, so we heard a lot. We heard a lot of terms. We heard a lot of what defect means outside and in software. And you know, in reality, the same things that you guys said, what a defect is, it's the same thing in the software. Really, so the reason I'm asking you to tell me what you think a defect is because expanding your knowledge, expanding your own vocabulary, and expanding your own understanding outside of software also helps you understand how it works in the software world, in the IT world, because it's very similar in terminologies. And so you know what you're looking for, right? You know what you're looking for. You know that a defect so when you identify, you know that it's a defect because it's not as part of the requirement. Don't worry about it, dear. We can just do a troubleshooting after the session to be sure. But so continuing, you understand now if something is not working, because you know what a defect is. You know when something is defective. Okay, so it's important that we know this, that we understand this. Okay, and so bug life cycle status flow. So just like we have phases in SDLC and SDLC, the software, the bug life cycle, defect life cycle has its own set of phases, and some of those phases range quite a few. They go from new, assign, open, fix, pending, retest, verify, reopen, close, duplicate, rejected, deferred, not a bug. Okay, so there's a lot of stuff here. There's a lot of stuff that goes into this. And so let's start with just this quick explanation here. So new is really when you find it. So the status of the defect is new, but then you move to assign it. So right, so say the QA lead right here, he finds a bug. Now he validates the bug. So now it gets, so if it's valid, yes, then it gets assigned to the dev lead. If it is not a bug, so it inquires the BA. So the BA is right here, the business analyst, right? So if it's a change request, if it is, then the defect status is deferred. So deferred means that it moves to a different release. So it goes into the backlog, right? So now this is like a new requirement here. If not, then the defect gets rejected and closed. But let's continue with a yes. So if it is a yes, if it is valid, then it goes assigned to into the dev lead, right? So the dev lead right here, so it's assigned to him, and now the status of the defect is open. Okay, so now that it's open, now the dev says, okay, hey, I fixed it. So he sends it to the dev lead, who now says, okay, hey, this is fixed. So now it's pending retest. So it's pending retest. So he gets it to the QA lead. Okay, so the QA lead now sends it over to the tester, to the QA. Okay, you guys. So pending retest. So this guy has to test it, and now he does the retesting. If he does the retesting, then now if it is not fixed, then it gets reopened. Okay, reopen right here. And so what happens if it gets reopened? It goes back to this guy or to this guy. If it is, but if it is fixed, then it goes into the closed status right here. Okay, there are a series of things that can happen, like it could be a duplicate, right? So there's already one that exists, so it's invalid. It could be rejected because once again, the BA says, hey, it's not a change in the request, so we're gonna reject this. Or it's not valid, so we're gonna reject it. It gets deferred if it is an actual issue, but it is a different requirement, right? It wasn't part of the requirement, so now it expands to something else, so now it gets deferred. Okay, and it could be that it is not a bug. So for example, hey, I found this issue. Okay, no, that's existing. It's not a bug. We know about it. We're okay with it. Okay, not a bug. Got it. Okay. So does that help you?
Teach, could you just go over that's the not valid part again? I just lost it somewhere.
No problem. Let's go into
Thank
that
you.
not valid again. Let's pick that back up. So the not valid phase. So basically what happens is that when you find a bug, when you find a defect, you have to make sure that it is an actual defect. So how do you verify if it's a defect? You go over with the development lead or the developer. Okay. So talking about it, is one way to do that, right? So, hey, John, I found this issue. Can you can you validate it for me? Hey, yeah, this is an actual issue. Let's set up a defect. Let's create a defect. Okay, good. Now it becomes a defect. If he says, hey, no, that is actually not part of the requirement. So it is not a valid defect as per the requirement. So now what happens is he has to go to the BA here, the product owner, and then a conversation with the product owner and the BA happens. And so they converse about the defect to make sure that it is an actual defect. Okay. So if it is an actual defect, as pointed here, now that means that this is a new requirement, because again, it came down here because it is not part of the requirement that they were working on. It is not part of the functionality that they were required to work on in this stage. So now they have to send it to a different sprint, say, for example. So they create a user story, it converts itself into a user story, it goes into the backlog, and after that backlog, it goes back into an iteration, it gets done, and then it goes through the whole test SDLC again. Did that help?
Yes, thank you.
Teacher, here is my, I have a question.
Yep.
There is a valid defect is not a defect, is a new requirement, so it can go back to the new sprint or something. But in your life cycle, you show there is a new, then assign, then open, then fix, then
So-
pending. So here I didn't find this part.
Yeah, so the only way that you make it to this part right here, into the fix and retest, right? The only way you can make it here
Okay,
is
yeah,
if
understand.
it is valid.
Okay, I understand. If
Yeah.
it is not valid, so it doesn't match with the bug life cycle.
It does, because this is still part of the bug life cycle.
Okay,
Yeah,
I understand. Thank you.
no problem. So yeah, everything here is part of the bug life cycle. But this is how we figure out if it is an actual bug or not. But the way that we figure it out is if it is in the bug life cycle. So it follows the breakdown.
Okay,
So we're
thank
gonna
you
see a
so
little,
much.
no
Thank you so
problem. And so we're gonna see a little bit of it more right here. So in the bug defect life cycle, right? So we have quite a few ways that we can that we can arrive into it, right? And so some of that is by actually noting the different steps that it takes. So as I showed you in the previous two examples, right? So the tester finds a defect. If the tester finds the defects, it gets a status of new. Okay. So now that that defect is in status of new, now it goes into an analysis. It could be an analysis there. So now it gets the dev lead or the whole team. So yeah, three amigos, and I'm gonna talk about three amigos later on. But the three amigos is a conversation between the tester, developer, and say the BA, for example, or the scrum master or the PO, right? So these three guys get together and they talk over the defect and they say, okay, this is a valid defect. Is it a valid defect? Yes. Okay. Then is it in scope? No, it gets deferred. But is it a valid defect? No, it gets rejected. Okay. But if it is not rejected, if it is a valid defect, it moves into whether it's in scope or not. Okay, and if you guys remember, we're talking about scope, right? Test and scope. So what scope means is that is it part of the requirement? If no, it gets deferred. So deferred, status deferred means again going into the backlog, because now this is a new requirement. But if it is in scope, then is it already raised? Did somebody already find it? So do we have already an existing defect for it? If yes, then it is a duplicate. But if not, if this is the only singularity of it, Then we move further into the bug life cycle. So now the developer starts fixing the code, right? So it's a sign. So this is where what it is assigned, and so it is set in progress. So the developer is working on the defect, and so once he fixes it, he comes and says, "Hey, I fixed it." So now the status changes to fix. Once the status changes to fix, the tester now goes into the picks up that defect, and he does the retesting for it. And very simply, the tester says, "Okay, did it pass? No. Okay. So if it didn't pass, it goes into a reopen status. So what happens if it goes into a reopen status? It goes all the way back here again. Okay, all the way back here again. So the developer now has to start fixing that again. So the developer now has to get more information, as to why isn't that fixed yet and whatnot. But if it follows the same process again, and it follows this process until it is actually fixed. So until the tester actually test that and he passes, that's when he goes into a closed status. Okay, and so that is the life cycle of a bug, of a defect, all the way from 1 to say 11. And once again, it works in different formats. Okay, if you find a defect, you set to new, you assign it to the developer. Okay, so you start going over whether it can be fixed, it is invalid, it is a duplicate, or whether it is deferred, not reproducible, or the request, or it is a request enhancement. Okay, there is a series of things that can deter a defect from being an actual defect. Okay, but if it is assigned and it is a valid defect, the developer has to fix it. Once the developer fixes it, it gets retested. And if it is not working as expected, it gets reopened. If it is working as expected, then it closes. So this is really the life cycle of the bug. It's very straightforward when you think about it. I gotta say, this was good. I actually finished on time today. So, guys, I'm happy that we're interacting more. I'm happy that we're understanding more, that you guys are picking things up. Very good. This is the end of today's lesson. I will again go over your assignment and grade it from a 1 through 10. And I will give you notes on where I think you could use a little more. Yes, it is more fun than the Bug Life movie. So with that said, guys, this is the end of our presentation. This is the end of our slide. This is the end of this section of slide. We're gonna go over this again on a Intro to Manual Testing Part 2 in the future classes. I'm gonna be sharing this entire deck now, so be sure to look at it in alignment with your previous 3 classes that we've taken. 4 classes actually. Yes, 4 classes. Sunday to, yes, 4 classes. So make sure that you're going over this along with the recordings. It'll help you. I hope that it will help. Your assignment for next class is to, by either using, let's actually say, you can use Draw.io. You can use this. So your assignment for next class is really to do a diagram, a flow chart, just like you saw here. Did I stop sharing already? All right, doesn't matter. So just like you saw in the last slide, the flow chart for bug life cycle, I want you to work on a flow chart that works from software development life cycle into the testing life cycle, into the bug life cycle, until it closes into the software development life cycle. This assignment is due for the next class. I think it's going to be on Wednesday. Next Wednesday is going to be the next class, I believe. But I'll confirm with you guys. But the flow chart is going to tell me how much do you understand of the current work material. So any questions in that assignment?
Yeah, quick question. Can
Yeah.
I like write it out on a piece of paper and then post a picture of it?
You can write it down on a piece of paper, or you can use the website that I just shared with you on the chat. It's called
Alright, cool.
draw.io. If it gets too complicated to use it, that's okay. Don't mind it. Just do a piece of paper, or do it on an iPad, a tablet, or something. Whatever you have that uses a pen, doesn't matter. But your assignment again is a flow from SDLC into SDLC into bug life cycle and into the conclusion of SDLC. So once again, questions about that? Great.
No, I got it.
Perfect. So
I have a question, teacher, here, the assignment.
yeah,
Yes.
go ahead.
Yeah. So we need to prepare the SDLC life cycle into that SDLC life cycle, then bug life cycle. So what is the actual result? I don't understand actually really. We know the life
Okay.
cycle.
So think about everything that we've gone through so far.
Okay.
Think about software development life cycle, where it starts,
Okay.
where it leads, where it follows. And so how does SDLC branches off from the software development life cycle and begins its own phase? And then within that SDLC, when does the bug life cycle happens and how it returns back into the software development life cycle? Does that help?
Yeah.
Good. You're basically creating the cycle, the entire cycle, not just of SDLC, but of everything together, how everything comes together, okay? And it all starts with SDLC, and it all ends with SDLC, okay?
Yeah.
So get that assignment to me by next Wednesday. Once again, you can use the website I sent you, draw.io, or you can use a piece of paper and pen, doesn't matter. Just make sure I get that with enough time so that I can review it before class next Wednesday, okay? If that is when we're gonna have the next class. Everyone, thank you very much again. Today has been a wonderful lesson.
you.
As
Wait, is there a
always.
class on Sunday?
There is a
Thank
class
you.
on Sunday, yes.
Okay, yeah.
Your classes are always on Sundays and Wednesdays.
Alright, cool.
Thank you so
Yes.
much.
No problem, guys. Enjoy the rest of your evening.